All right, so we're going to do vectors in 2D. I'm not going to do the harder versions of this until next week. I don't want to overwhelm you guys. I'm just going to give you the stuff you probably are already well aware of. I'll show you how it relates to physics. I'm talking about Pythagorean theorem, SOHCAHTOA, sine, cosine, and tangent. Stuff you probably already know. I'll go through it. I'll show you the homework, and then you'll have time to ask me any questions. Maybe this quiz, maybe you're going to do some last-minute questions before your test tomorrow. Again, I won't be here tomorrow. Make sure you don't bring your cell phone in. You can come in early if you want. Just get started. I'll leave those instructions for the sub. And it's Mr. Leenders, if you know him. So he's a nice guy. You guys will all be spread out here, and it'll be all one-dimensional kinematics. So nothing from this point forward. And all that stuff I put on the whiteboard yesterday, those are the usual suspects. Oh, like around 30 marks. Usually about 10, 15 multiple choice and 10, 15 numeric written. All right, good people, we're going to talk about vectors. So I want everybody to pretend you're a mathematician, hard at work. How would you be a mathematician hard at work? Let me demonstrate. Let me demonstrate. This is a mathematician hard at work. Got my feet up on a desk and I'm staring at the ceiling. I'm thinking, right? Anyways, everybody look at the ceiling. Look at the ceiling. Imagine there was a fly. Imagine there was a fly walking around the ceiling. There's a fly on the ceiling walking around. How could you define that fly's position? On the ceiling. How could you tell somebody where that fly is? No, on the ceiling. So, this is the exact same thing that happened to Mr. René Descartes in France in the Enlightenment. Like, he's staring at his ceiling, and he's like watching a fly, and he's like, oh, I could give an X position and a Y position, left, right, up, and down, right? Two-dimensional surface, the ceiling. So that's what we're going to be doing. Two-dimensional vectors only. Like, if you get to calculus in university levels, they do three-dimensional vectors. So X, Y, and Z. That would give you a position or a speed in the three-dimensional world. We only do our problems with 2 dimensions. Okay? So X's and Y's. You guys can handle that? Okay. So again, vectors are represented by arrows. One end of the arrow is the tip and one end is the tail. Okay? And if those vectors are not perfectly left and right or up and down, for example, they are like at a diagonal, you just do some right angle trigonometry, with which you're all probably pretty good at. You need to break it into an X component and a Y component. So how could I travel that diagonal? Well, I could just go over so much and then up so much. Okay? That's what we're going to be doing. This is called resolve into components. Resolve into components. Typically, they call the hypotenuse capital R. That stands for like result or resultant. And then you'd have the X component and the Y component. So the X component and the Y component combine for the resultant, the hypotenuse. And that arrow, the size of the arrow gives some indication of magnitude, how much, and the angle gives you the direction. So maybe you're going to take your boat 5 meters per second, 30 degrees north of east. How much and which way? And the math is nice. It's all just trig. Okay? And this one's key, this last bullet. Tip to tail. That's crucial. Tip to tail. That's how we add. Okay? So like if I did this and Then I decided to change my mind, and then I did this. It's like, okay, where did I end up? Well, I ended up from my origin right there. Okay, that didn't show up. There it is. So it's always tip to tail. Tip to tail. Okay? That's how we line up vectors and add them up. Tip to tail. Okay. So vector components. Let's just do some basic trigonometry here. In this case, with our 30-degree angle, the y component is the opposite side. The right angle is down in that corner, so this 20 meters per second, this velocity vector is our hypotenuse, and this x component is our adjacent. That should be pretty straightforward for you. You use those labels to build 3 trigonometric equations. Sine of 30 is equivalent to the opposite side over the hypotenuse. You guys know this from trigonometry. SOHCAHTOA. So if we're going to do the sine of this 30-degree angle, we need the opposite divided by the hypotenuse, which in this case is y divided by 20. And then we can solve for y, of course, by multiplying by 20 on both sides. Almost identically, you can do the same thing with cosine. 20 times the cosine of 30 will be the x component. Does that make sense, you guys? Because it would be the exact same. Just replace sine with cos and replace y with x, right? It does the adjacent over the hypotenuse. So you'll end up with that formula. What's the other one I'm missing? Tangent of 30. Tangent of 30 will be the y over the x. And we don't know either of those. But once you find y and x from up above, it should work out that it would be equivalent to the tan 30. All that rings a bell for you guys? Okay. Doesn't? Okay, so Math 10. Math 10C, Science, I don't think they do it in Science 10, do they? No. Okay. A girl runs at 30 degrees west of north. Now this is challenging for some people at first, so I recommend that you just draw a grid like this. Give yourself a grid like that. Now I don't know how you guys remember this. North and south is easy for me, but for some reason, I've been doing this a long time, I get my easts and my wests mixed up. I'm not sure why. So when I was a kid in elementary school, it was never eat soggy wheat. Yeah. 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 Never enter Santa's washroom? Or Santa's workshop. Yeah, workshop. I must have misheard that. That's why. Okay. So let me just give you guys a quick debrief on how to read the direction here. If you're west of north, what quadrant are you in? Good. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you're west of north, you're in quadrant 2. And then by how much? So you just have to go like a little bit over. Okay? And this is your vector. The vector itself has a magnitude of 2.5. The hypotenuse is 2.5. Okay? And of course, you can throw the unit on if you wish. The vector itself is 2.5 meters per second. So what does this picture tell you? It tells you that the person's motion is in this direction. How fast? So how much? And which way? Magnitude and direction. A vector is fully described by two components. How much and which way? You guys okay with that? What would 30 degrees north of west be? Kind of like that one? All right, let me get these little marks off the screen. And the question here, what are the x and y components? So let's do the x component in nice blue. Now, first of all, just think about Rene Descartes looking up at the ceiling. What could he know about the fly? He could know its left and right, and he could know his up and down. So for this one, are you going east or west? West. So the x component is like this. And are you going north or south? North. So the north component is like this. What do you notice about those two vectors? How do they line up? Beautiful. Tip to tail. Okay. Tip to tail. Tip to tail. Okay, so if our 30 degrees, I'm just going to clean up this diagram a bit. It's a little bit messy. If this 30 degrees is down in here, what does it make the overness, the left and right? Opposite, adjacent, or hypotenuse? This one up here is opposite? Good job, Maria. And, yeah, good. The y component is the adjacent. Does anybody have issues with that labeling? Straight across for the opposite. Now I'll use my pointer here. If the angle's down here, you have two sides that are essentially right next to it. They're beside it. But only one of them can be the adjacent, right? The one that's not the hypotenuse. Where's the hypotenuse always? Directly across the right angle. So if you could at least just find out which one's the hypotenuse, it's not too difficult to determine which one's op and adj. Let's call this in the op, let's call the op Vx. Why would I call it Vx? It's the component of the velocity in the x direction. So what would I call the adjacent? Vy. Now, which trig relationship will do the Vx in this case? Good. Sine 30 will be opposite Vx over hypotenuse 2.5. Solving for Vx, 2.5 sine 30. You just times by 2.5 on both sides. So similarly, you'll have one for cos. Cos does the adjacent. In this case, the adjacent is the Vy. Over the hypotenuse again, and you solve for the Vy. What do you... You're probably not in degree mode. Yeah, sine 30 is half, so you'll get 1.25. Should be in degree mode. And 2.5 cos 30, it should be about maybe 1.8 or something. 1.9, what do you guys get? 2.1? 2.2? Okay. 2.2. What's the third decimal? 2.16? 2.165, so 2.17, thank you. You got that figured out? Okay. And remember, we're smarter than the calculator, correct?
No.
So that Vx is 1.25 meters per second. Help me. west. And that Vy is 2.17 meters per second north. These are the components. Those are the components. Not too shabby, right? So we're going to revisit this one next week. And if you could skip ahead to this one. We will revisit these slides. Just got to flip a page ahead. Okay. This is the last question we'll do. I'll give you the rest of the time for yourselves. I just want you to think about this one. You're on a walk and you travel 10 kilometers north. You can put that in. And then you travel 12 kilometers east once you're finished walking north. So both of your vectors are completely horizontal and vertical, respectively. When you have this situation, like if you're given the right angle, I want you to always use the right triangle method. It's just so simple and so nice that why not? Which way do I draw my resultant vector, which I'll do in black? Is it upright or down left? Did you say that because I went like this? It's tip to tail. Let's just say we had to start here because look at the way the vectors are drawn. So you went up and then you went over. So the result is you ended up from your origin, you ended up like this. Do you agree? Okay, that's the one you want. That's the one you want. Remember, the components are tip to tail. And then it's from where you started to where you ended up. So in this case, we were given the components, which are drawn tip to tail, and you have to find the result. In the last question, we were given the result and had to find the components, right? So now we're working backwards. Now, if this was math class in grade 8, what would you do? Pythagoras. Okay. 10 squared plus 12 squared, this will equal the resultant. What is it? 15.62, so 16 kilometers. Am I done? Beautiful. This vector, this displacement vector, r, you could put a little tick on top to help you remember that. This displacement vector r is not fully described without how much and which way. So I want you to find this angle. Not the other one. Even though the other one is like sort of acceptable, I wouldn't recommend you do that one. I recommend you find this one because that's the angle that you're taking at the start. So that's the one you want to find because you're starting down here. How can I find that angle theta? I would just use the 12 and the 10. Don't use the 16 that you found because you're going to get error if you round. Just use what the info they gave you. 12 is which? 10 is, that one is tangent. So tangent of theta will be op over adj, 12 over 10. So of course theta will be, show me the second step. What's the second step? What do you type in your calculator? Second function 10, and then you input this 12 over 10. Some of you with older calculators, make sure you put the brackets in. Remember, you have to be in degree mode on your calculator. Stuff that I'm just going to quickly go over because you guys are grade 11. Most of you. The answer is 50.2. So 50 degrees, because it's 2 sig digs, right guys? Looking at, you only got 10 and 12, 2 sig digs. Now, that 50 degrees is sort of ambivalent. Yeah, it's ambiguous. Ambiguous. 50 degrees, which way? Very nice. Do you see how naturally she did that? You travel north and then you travel east. So you are what compared to north? Beautiful. Because this angle that I have here, if I started at the north, this is east of north. Sometimes students will get that a little bit mixed up, east of north. So we got to slide that right here, 50 degrees east of north. Yep. Northeast would be marked wrong. And northeast is 45 degrees. Northeast is exactly halfway. You could, yeah. But most people just put 45 degrees north of east. Okay. Final answer, 16 kilometers, comma, 50 degrees east of north. This is your final answer.
Is that how you're going to want us to write this?
Yep. Yeah. You have to, if you want to do well. Okay, so 20 minutes left. If you guys aren't using the time, I'm just going to go back to teaching. So please, if I give you time, use it effectively. Don't just sit here talking. The homework, let's get you going on just this. We'll revisit the other stuff later. So now you're skipping quite ahead in your workbook because the workbook you have bounces around all over the place.